Hi everyone. We're going to look at upper and lower bounds as far as being able to take a look at where possible zeros for an f of x function might be located. We have a rule to help us with this. If k is greater than or equal to 0, so positive, and every back up. Try to go too quick. Sorry about that. And every number is non-negative. Then our value k is an upper bound. So that means there will be no zeros bigger than whatever that k is. All right. If k less than or equal to 0, and every number is alternating non-negative, okay, then k is a lower bound. Okay, so then that means we would have zeros in between somewhere. All right, so let's mark this up just a little bit. All right, so what do we know? If every number is non-negative, non-negative, upper bound. If our numbers are alternating non-negative, then we'll have a lower bound. Okay, so let's look at an example to see what all this is about. So let's start with our favorite function, f of x. And let's say it is this time 2x to the fourth minus 7x to the third minus 8x squared plus 14x plus 8. Okay, so a nice healthy polynomial. And the directions say prove that there are zeros, or that the zeros lie in the interval from -2 to 5. Okay, so in other words, I'm saying to you that I have a potential lower bound at -2. I have a potential upper bound at 5, which then will mean that all the zeros for this f of x have to lie between those two values, the upper bound and the lower bound. Okay, so let's take a look at this. So we're looking to see about the signs of our quotient. Okay, I'll keep that about right there. So let's begin with the -2. All right, and we're going to use our friend synthetic division to help us out here. Okay, so my potential k value is -2. So I'm putting my little box, and I'm going to set this up for synthetic. Okay, all terms are here and in descending order, so I'm just taking off the coefficients. So 2, -7, -8, 14, and 8. Skip a line, draw our line, first number down. Okay, so then we're going to multiply. We get -4, and then remember, add down here, so -11. Multiply again, so 22. Add down, 14. Multiply, so we get -14. And then multiply one more time. We have 28. It's going to put down here in the corner. 36 is our remainder. Okay, so for k equals -2. Okay, k is less than or equal to 0. Okay, so that's like that first case up here. If I should highlight it. Okay, k is less than or equal to 0. Okay, and okay, what about the signs? Okay, are they alternating, or what is our case? Oh, you know what? I highlighted the wrong place, didn't I? Ha! Great! Way to go. I've been too many videos today. I apologize, everybody. Messing up our notes here. So this said k greater than or equal to 0. We actually have k less than or equal to 0. My bad. This one right here. All right, so let's try that again. So if k is equal to -2, Okay, that says k is less than or equal to 0. So I'm looking back over here. And the signs are alternating non-negative. Okay, alternating. So we go positive, negative, positive, negative, positive. That's what I mean by the signs are alternating. Okay, so what that does is, should I say here, numbers all alternating. Okay, so k equals -2 is going to be a lower bound. I got so excited that it worked, I got marking things in the wrong spot. Sorry about that. Okay, now let's test for the upper bound. Let's take the 5, okay, that was given to us over here. Okay, and we're going to say, all right, 5 is the k value for the upper bound. We're going to do synthetic again. So 2, -7, -8, 14, 8. Skip a line, draw a line, first number down, just like before. I don't want to go too far so we can keep our rules right there. Okay, so when we multiply, we have a 10. So that would add down 3. 15, add down, so 7. 35, add down 49. Now the numbers are getting big. 245, and our remainder here is 253. Okay, so this time, what is our conclusion? Okay, well, for k equals 5, okay, that says to me that our k is greater than or equal to 0. Okay, now I'll go up here and I'll circle. K is greater than or equal to 0 up at the top, okay, to match this one. Okay, so what's it supposed to be? Every number in our quotient is non-negative. All right, did that happen? Well, positive, 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 positive. Sure enough, that's what happened. So our quotient numbers are all non-negative. So therefore, so we can conclude, so k equals 5 is going to be an upper bound. Hooray! It worked. Okay, so cool. All right, so what kind of conclusion do we make? It says, so all real zeros lie in the interval from -2 to 5. That's what we just proved. All right, fantastic. All right, so let me scroll up here just a bit, get a fresh start. Okay, let's start with another polynomial. Let's suppose this time we have f of x equals, okay, I don't know if I want to change or keep the same. What do we have? We had a nice one here. I'll tell you what, let's just keep this same polynomial. So I'll just copy it back here so it's closer to what we want to do now. 7x cubed, 8x squared, 14x plus 8. Okay, so at this point in time, since I'm going to use the same polynomial again, we know that all our zeros should lie between -2 and 5. We just proved that with lower and upper bound. All right, so let's tie in here a little bit of our rational zeros theorem. All right, so from the constant, our p list down here, plus -1, plus -2, plus -4, plus -8. Okay, from the leading coefficient, the q list, plus -1, plus -2. All right, so in looking at all potential rational zeros, okay, we're going to have plus -1, 2, 4, 8, all over, plus -1, plus -2, which when you simplify this out or calculate, I don't know if you calculate or just go through the list, you've got 1, 2, 4, plus -8, and then plus minus, everything else reduces, 1, 2, 4, it looks like 1/2. Okay, so now if you take your calculator, your graphing calculator, and you graph so that you are able to see on your calculator on the x-axis from -2 to 5. All All right, see if I can sketch what I got. I see here at -1/2, I see a 0. Okay, let me see. It does something like this. It kind of comes down and back up, down and back up, kind of like that. Okay, and I also see over here at 4, okay, I see a 0, and while there's a 0 here, it wasn't a nice number, if you will. Okay, all right, so what does that do for us? Well, let's see if we can figure out now all the zeros. So let's take the 4. It's a nice whole number. It's nice to do synthetic with. So once again, I'm going to set this up. 2, -7, -8, 14, 8, so that we can go through synthetic. We're going to reduce the degree on our polynomial and see if that'll help. All right, so first number down like before. So we have 8, add down is 1, multiply, add down, multiply, add down, and lastly, multiply, add down. Woohoo, look at that. Remainder is 0, which I hope you were expecting. Since we see it on the graph as a 0, that confirms that we do, in fact, have a 0. So x minus 4 is also a factor. Okay, and I hope you're all shaking your head. Yep, that makes sense. I have a 0, so I have a factor. Okay, so when we started this one, okay, our f of x was x to the 4th. So now when we have our quotient, it's going to be down here to 2x to the 3rd. Okay, so now from the graph up here, okay, so up here, we had a second 0 at -1/2. So I'll tell you what let's do. Let's just build right next to this -1/2. And let's run through a second time synthetic division to see if we can drop our level down one more time. Okay, so let's bring this down. The 2 multiplied by -1/2 is -1. Add down is 0. Multiply another 0. Multiply -1/2 times -4. So we get a 2. Hey, looky there. We have another remainder of 0. So we now know for sure that x equals -1/2 is a 0. Okay, and we know that x plus 1/2 is going to be your factor. Now, we don't usually leave a factor like that, so I would tell you to remember to do a bottoms up and write your factor as 2x plus 1. Okay, so we've got 2 factors now. All right, so now let's think about what we have left over on our second synthetic division. When we come down here, we now have that to be 2x squared. Okay, so in our world of factors, let's put this out in red. Okay, so our f of x now can be thought of as x minus 4. Okay, that was our first factor over here. We now have a 2x plus 1. And we also have what's showing up here as the bottom on our last quotient, 2x squared minus 4. Okay, so really we could do a little bit of work on that last factor. Like we could pull a 2 out of here because there's a 2 in common and be left with x squared minus 2. Okay, so in the end, a nicer way to write this would be put the 2 in the front. Then you have a factor of x minus 4, a factor of 2x plus 1, and a factor of x squared minus 2. Okay, so that's all of our factors for f of x. So then below that, we can take a look at the zeros. Okay, so from your first term, or first factor, x equals 4. Okay, from your second factor, x equals -1/2. Okay, and then this x squared minus 2 is interesting. So set it equal to 0 if that's bothersome, and then just solve that. So add your 2 to both sides. So x squared equals 2. Then square root. But remember, when you're solving on that square root, introduces your plus or minus. So that actually gives us 2 more roots. Okay, so we have a total of 1, 2, really 3, 4 zeros. And if you remember back up here at the way at the top, okay, our degree was 4. So we could have expected at most 4 zeros. And sure enough, we did find them. Okay, so that's tying a lot of things together, and that was a nice long problem. Another thing we could do if we really wanted, we could go through and do like f of 4 and check the remainder, f of negative 1/2 and check the remainder, and so forth. One would hope those come out 0, or else somebody made a mistake. Okay, I didn't, so don't worry. All right, have a great day. Lots of stuff going on in that problem. Upper and lower bounds is what we started with. Thanks, everybody.